In this chapter, we are going to cover the conduction heat transfer at steady state. We will cover only important things that are necessary for your exam as well as that will aid your preparation for a good and as well as your semester examination. So let's begin. As we know that we are only going to cover the important formulas and important rule that you have to remember for your exam. Okay, let's begin. I'm not going to cover all the theory. I'm just going to tell you the important formula and important theories that you have to remember every time. Here is the general formula of heat conduction. You already know that, and you must remember whenever there is angle at transfer in the transfer of heat of like surface area, and you can use this formula. You must remember this. And I think this one is important formula. You must remember K delta T is equal to like delta T del is equal to I del by del x j del by n k del by del z. This is the value of del. And in case of three dimension, you will use x, y, z tree. In case of two dimension, you will use only x and y. And in case of one dimension, you will use only x. Okay. So you must know the what is steady state and what is transient state for the transfer. And okay, here is the coding. You can see here the heat transfer. And if you are planning for a semester exam, you must prepare the derivation. Otherwise, no need to uh, derive everything. You just remember this formula. This formula is important for your heat transfer question. And you will see it in different exam also, and you can also see the some type of like question in your exams. Okay, so please remember this formula. Next, this is the same formula. The difference. Okay, in case of three dimensional heat, well, you can use this. And please remember this formula. Okay, this formula. And here one important thing is you have to remember is alpha. Like alpha is thermal diffusivity. Okay. So many times it can be it has been asked for your competitive exam like GATE and other exams like what is thermal diffusivity and it is formula. And if you remember, you can directly go for right answer. Alpha is equal to K by rho C. Thermal diffusivity. There is the alpha. So please remember alpha. Alpha that is thermal diffusivity and this equation also too. And please also remember this equation when you put del T by del T small t is 0, you will get this equation and this is called Poisson equation. And this directly asks what is Poisson equation, and if you remember, you can give the answer. And if there is no heat generation, this will become a Laplace equation. Okay, so this is called Laplace equation. This is Poisson equation. This is three-dimensional heat equation. Okay, so please remember all three and the different between them, between in between. Okay, what is Laplace? What is Poisson? Okay, so this can also be written as you can remember. Okay, so that is the important thing. This equation important. Please remember. Next, if you see something is important, I will tell you that you should remember or not. And in case of derivation, you can refer the book. If you want, I can share the book. Just if in case you want, if possible, you can remember it one of these equation. Okay, this you must remember one equation because it will be directly asked. No, there is no need for. If you plan for semester exam, you can derive it. But if you are planning for other examination, you must remember it because it will be asked in your exam for the correct option. So okay, so please and otherwise you can remember it. This also okay. This is the same equation. And you can remember this equation. Whether 2.21 this and 2.22. If you can remember this, that would be sufficient for your exam. Okay. So please remember this equation. Next, in case of spherical coordinate, what do we have? And what we have to remember? I'm not going to tell everything I'm not going to derive, but what I'm what we are studying only important formula that you have to keep every time in your mind so that you can get the maximum use of your knowledge of the heat and water. Okay. So if you can remember. I don't think it's important, but if you can, you should. Otherwise, no problem. But remember this one, this one. Okay. This will be sufficient for you in case of study only radial direction. Okay. Condition. What is the condition for this equation? This equation reduced to this because if there is no heat source present and heat flow is steady and only in radial direction. In this case, you will use this formula directly. Okay. So no need to memorize all this. Okay. Just remember this. Steady state, steady heat conduction in simple geometry. Simple geometry like plane wall. Okay. So in this case, you can use this equation, and when there is no heat generation, Q will become zero, and steady state. This will also become zero. So this is the del 2 t by d d2 t by dx square. Okay. This will become del. And this if you integrate this, you will like this. You will get the two coefficient. If you apply boundary condition, you will get this temperature equation, and this will be similar to this equation in case of steady state no heat generation. Okay, with heat generation, we have told you that this equation is important for you, and in case of heat generation, we keep q by g, q by k in your equation, and then integrate it. Apply boundary condition, you will get this equation. Okay, so in case of steady state, you will get this equation when you apply temperature, and you will get this. This is the basic equation. You must remember, if you know this, you can easily find whether it is plain heat generation with heat generation or without heat generation. So you just remember one equation, okay? And this equation, you will get all the things. Write it here. If you remember this equation, you will get all the things done. Right. That's why I told you, you have to keep that equation in your mind so that you can solve the equation. Okay, let's go to the other topics. We have seen this, and I think not much thing. This is the previous thing. You have to, you don't have to worry. This is the same thing. Just keep the temperature difference theta, and this will end up same result. Okay, so no need to worry. Just basic. You should remember basic equation so that you can use and derive the equation. Okay. But in this case, cylindrical wall, in case of cylindrical without head generation, this is the same question. But I told you the previous question you have to remember, and from that equation you can get the result. Just integrate and find the result after applying boundary condition. This is the same formula for because of cylinder 2 by KL, T1 minus 2 per L, half not by RL. Okay, so you just remember fundamental equation and you can find all the derivation. This is the same we have told you, and you will remember this always. And this is also the same. No, with heat generation, in case of with heat generation, this is the basic equation Q by K. Okay, and from here you can find the variation of temperature by integrating and applying the boundary condition. Okay, at R equal to 0, that dt by dr is equal to 0. So what you have to do, you have to remember what I have told you, the fundamental equation in three cases: pairs, is plane wall and cylinder. When you remember that equation, you can solve all the things easily. In case of spherical one, you can see here, this is the same equation what I have told you earlier. If you remember that equation, you can easily find the temperature variation after solving it. this equation. Okay, here is the equation. 4 pi k r naught r by t1 minus t2 upon r naught upon ri. Okay, with heat generation, this is the same case. You write fundamental equation with heat generation and integrate that, and you will find the different equation. And after applying the boundary condition, so critical radius of insulation, please mark it as an important question because it will definitely be asked in some of your exam, either or semester exam or some competitive exam. This will definitely be asked, as much as I know, because it is one of the most important topic in this chapter. So please remember what is the critical radius of insulation and how to derive it. If you are planning for semester, you use how to derive it. Otherwise, you can directly memorize R is equal to K by H. Okay. In case of cylinder, R is equal to K by H, and in case of sphere, you will also see here is the critical radius of insulation and Q maximum. At critical radius of insulation, Q will be maximum. Please remember this. At critical radius of insulation, Q will be maximum. So, in case of spherical one, you can use this 2K by H. Remember both equations, K by H and 2K by H. These two are important things. So, note and next topic, extended surface fin. Fins is also important. And here we have told you Fourier's law. Okay, this will touch it minus t. And type of fin you can see here. And what are the use of fin? What are the definition of fin? And what are the type of fin you must know if you are planning for your exam. So these are the important things you must read before going for the exam. And here are the type of fins. Suppose uniform cross-sectional fin, and here are some derivation. You some of the formula you must remember. Like this equation of sin q is equal to q in q is equal to k divided by x Fourier snap qx plus dx. This is the equation. Just this is expansion, and you will get this equation. Okay. So will you remember this also? M is equal to hp upon under root hp upon k. After that, you will end up with this equation. Okay. So not to worry, just read about the some fundamental things of thing. You will get the proper equation. And if you come to the formula question, you will, if you remember the formula, you will get the answer. This is the important thing. Please remember this. Okay. K and theta tan hyper. This one is important. Is insulated at tip. This one, please remember this formula. Okay. And here is called H upon K. K and theta tan upon whole ml. Insulated at tip, like fin had certain length. Okay. This is the one case. And then K and theta for infinitely long fin. These two. This and this. Where is this 2.97 and that 2.101. These two are important. If you can remember these two, you will be able to solve the question. Okay. And for with condition, this is for infinite, and this is for insulated atom. Okay. Right. So both the case important. Please remember both case that these two are basic things. If you can remember, you can remember that two question. Otherwise, field performance also important. You please remember Q upon H theta field performance. Heat transfer with field upon heat transfer without field. You can see these performance some of in your exam, either competitive or semester exam. So please remember this also. Field performance. Heat transfer with field, heat transfer without field. Okay. And this formula also important. for field. Remember this formula. Okay. You can read this theory. I'm not going to cover the theory. I'll just tell you the important formulas. But you have to keep in your mind. You can remember efficiency, also important. Okay. Actually transfer for maximum transfer efficiency. So this efficiency 10 half for all camel upon ml is also important. Remember this. Okay, I told you. Right. These are the type of fins. What fins? Let me see. Anything important I will tell you. Definitely. Limitation of extending surface. I don't think it's much important. If you have time, you just read and go through it. You will get some insight. If you read the book, you will get some insight. You can know what are the important things you have to keep in your mind that 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 are going to help you in your exam. I don't think these are important things. So if you have time, you can read. Otherwise, you just see the formulas and try to memorize all the formulas. Don't skip any. Because if you skip any formula, you will end up with losing. Because if you miss anything, you will not be able to solve the question. Okay, so please remember all the important formulas. One three-dimensional heat, steady state heat conduction, as as much as your semester and some exams are concerned, no need to go for three-dimensional or more than one-dimensional because they are not going to ask about this. They will ask only one-dimensional. If you want, you can use two-dimensional. No need to go for three-dimensional pattern. Okay? So just go at two-dimensional because only two-dimensional will be asked, like x and y coordinate. Okay. So here are the question for two-dimensional. You can use it, and no need to worry. This is not the case. If you can integrate, you just integrate. Otherwise, no problem. It is not going to ask in any exam. This is the equation of Laplace. Okay, we have earlier told you. Graphical method. No need to do anything here. It will not be asked. Okay, let me see if something is important. And these are also important. If you can, you just try to solve all the question. Okay. If you solve all that, you will get the safe factor for different case. You just solve all the safe factor question. These are also important. What is numerical method? Knowing and these are not important for as far as your semester and as far as your exams concerned. So no need to go study these are not good things. This will not be asked. God's idol is not going to ask. This is not important, not much important. Electrical analogy, three-dimensional. I have told you, no need to study three-dimensional. Just study one and two, max two-dimensional. Okay, you will be able to solve the question. Now you can see the question and you will try to solve the question as we have studied. These are the simple questions. You will get them. If you practice this question, you will be able to perform well in your exam as well as your semester. Okay. So let us just solve, and if you have any problem, you can ask me directly. Okay, thank you.